Afternoon, dear children. Today I am going to discuss first chapter, real numbers. In this chapter we have to study four concepts: decimal expansion of rational numbers, Euclid's division algorithm, fundamental theorem of arithmetic, and proofs based on irrational numbers. Among these all, we've already studied the Euclidean algorithm. So, today I am going to discuss the fundamental theorem of arithmetic. The fundamental theorem of arithmetic is related to prime factorization. Okay, dear children, I am very sure that all of you know prime factorization method. So, along with this prime factorization or this fundamental theorem of arithmetic, today we will discuss how to find out LCM and HCF of numbers. Okay. Ready, dear children? All of you take your math notebook and write the heading Fundamental Theorem of Arithmetic. Fundamental Theorem of Arithmetic. Fundamental Theorem of Arithmetic. Okay. Let me explain what is it. Yeah, dear children, fundamental theorem of arithmetic is related to prime factorization of numbers. Yeah, we can start with one example. Yes, a number 84. Yes, do the prime factorization. 84 divisible by 2, 42 divisible by 2, 21 divisible by 3, 7, then divisible by 7, 1. This 84 equal to 2 into 2 into 3 into 7. This is one method. Yeah, in another way how can we do? Yes, you try, dear children. Is it divisible by 3? Yeah, 28. It's divisible by 2, 14. Divisible by 2, 7. Yes. That means we did prime factorization of 84 in two different ways. Both are same. Yeah. In first case, we can write 84 as 2 into 3 into 7. In the second case, 84 equal to 3 into 2 into 2 into 7. Yeah, that means, dear children, this 84 we can write in both the cases. See here, 2 2's and 1 3 and 1 7. 2 2's, 1 3 and 1 7. Yeah, I am going to write this in ascending order. That means in both the case there are 2 2's, 1 3 and 1 7. That means we can write 84 equal to 2 into 2 into 3 into 7. That is same as 2 square into 3 into 7. Yeah. In first case, 2 into 2 into 3 into 7. Second case also, we can, if we just change the order, we can write as 2 into 2 into 3 into 7. This is fundamental theorem. That is, every composite number we can do its prime factorization, and that is, the factorization is unique while writing ascending order. That is, if there is any change in order while writing ascending order, it will be same. Okay, all of you write in notebook this one. First, fundamental theorem of arithmetic. Below that, example 1 or question number 1, and write it. Yes, let's try with another example. Which one? 100. One is starting with 2. 50, 2, 25, 5, 5, 1. Yes, 100 is a number divisible by both 2 and 5. So divisible by 5 also. 20, 2, 10, 2, 5, 5, 1. In the first case, 100 equal to 2 into 2 into 5 into 5. In the second case, 100 equal to 5 into 2 into 2 into 5. That means there are in both cases there are 2 2's and 2 5's. 2 2's and 2 5's. That is 100 we can write in ascending order from the both in ascending order while writing 2 into 2 into 5 into 5 equal to 2 square into 5 square. Yeah. Here also according to fundamental theorem is we can do prime factorization if the ways are different, but while writing in ascending order, that is unique. From both one we can write like this. Okay, write this also. Okay. Yeah. Now we can write the statement. Theorem. Yes. Every composite number can be expressed. Every composite number can be expressed in the bracket factorized. That is, can be expressed or factorized in bracket. Close the bracket. As a product of primes, comma, and this factorization is unique. Put a comma. Apart from APART. Apart from the order in which the prime factors occur. Apart from the order in which the prime factors occur. Once again, every composite number can be expressed or factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. Okay, clear dear children? That is, every composite number we can factorize, then that factorization is unique apart from the order. There may be change in order, but while writing in ascending order, that also will be same or unique. Then below that you write remark. Yes. The prime factorization of a natural number is unique. The prime factorization of a natural number is unique. Put a comma. Except for the order of its factors. The prime factorization of a natural number is unique except for the order of its factors. Yeah. In general, given a composite number x, small letter x, we factorize it as x equal to, yeah dear children, yes, 1 minute, x, I will show here, you write x equal to p1 into p2 into p3 into etc. pn. That means a composite number x we can factorize. This p1, p2, p3 etc. are the factors. Then we can write its prime factors. We can write the product of the prime factors. X equal to p1 into p2 into p3 into etc. pn. Then this in ascending order. So we can write p1 less than or equal to p2 less than or equal to p3 etc. less than or equal to Pn. That means this is a general. Generally we can write every composite number. We can write as the product of primes that in the ascending order. Okay, you write x equal to P1 into P2 into P3 into etc. Pn. Pn where P1 comma P2 comma Pa3 etc. Pn are primes and written in ascending order. P1, P2 etc. Pn are primes and written in ascending order, that is P1 less than or equal to P2 less than or equal to P2, P3 etc. less than or equal to Pn. Okay, dear children. Then, yeah, in textbook exercise, there are so many questions to do the prime factorization. That I will give as homework. Last is, I will tell you which of them are homework. Then, write the next one question. Question number 1. Can you see the question here, dear children? This example 5. Consider the numbers for Sdn. Consider the numbers for Sdn where n is a natural number. Where n is a natural number. Full stop. Check whether there is any value of n. Check whether there is any value of n for which 4 is the n ends with the digit 0. 4 is the n ends with the digit 0. Yes. Did you understand the meaning of those, dear children? Yeah, what I'll explain. We had, the question is, a number 4 is the n, given 4 is the n. By substituting different values of n, if it is a 1, n equal to 1, it will be 4 is to 1. If n equal to 2, 4 is to 2. If n equal to 3, 4 is to 3, like that. But n value is not given. We had to find out the value of n with a condition. If we are substituting the value of n, that number should end with 0. For example, if I am giving 4 square equals 16. Yeah, that n equal to 2. It's not ending with a 0. So, n is not 2. If 4 is the 3. That is 4 into 4 into 4 into 4 into 4. That is, what is 4 into 4 into 4? 16 into 4. What is 16 into 4? 64. Is it ending with 0? No. We had to find out a number for the value of n and check it whether it will end with 0. Or is there any value? Yeah, dear children, is there any value of n such a way that the number ends with 0? Yeah, dear children, no need to substitute different value. Important thing is, if a number is ending with 0, we are studying here all the concept related to factorization. If a number ending with 0, for example 10, yeah, what are the factors? 2 and 5. For x prime factors only, 20. What are the prime factors? 2 and 5. Then next, 100. What are the prime factors? 2 and 5. That means, generally we can tell if a number ending with 0, its prime factors are 2 and 5. 2 and 5 should be there. Is it? Then our question, 4 is the n. We had to factorize this one. 4 is the n. N's value we don't know. That's why we can't factorize n. We can factorize 4. 4 as 2 square. 4 is 2 square whole raised to n. 2 square whole raised to n means 2 raised to n. That is, in the last factor is in the case of 84 and 100, we wrote 2 square into, like that. Here 2 raised to n. We can see a prime factor 2. But is there any 5? No 5. only it has forest D and has only one factor, that is 2 only, not 5. That's why very sure that there is no number, there is no value of n such a way that the number will end in 0. No value for n, because while writing the factor, if there is 5, we are very sure that the number will end in 0. But here no 5. That is the proof. I think all of you clear? Thing is, there is no value. We can conclude that there is no value of n such a way that the number is ending with a 0. The reason is there is no factor 5. Okay. Yeah, dear children, we can start the answer like this. If the number 4 is the n, if the number 4 is the n, for any n, were to end with the digit 0, then it would be divisible by 5. If the number 4 is the n, for any n were to end with the digit 0, then it would be divisible by 5. That is, prime factorization of 4 is the n. Prime factorization of 4 is the n would contain the prime 5. Would contain the prime 5. Yeah, this is not possible. This is not possible because 4 is the n equal to 2 square whole raised to n. 4 is the n equal to 2 square whole raised to n equal to 2 raised to n. Yeah, below that, the only prime in the factorization, of 4 is the n is 2. The only prime in the factorization of 4 is the n is 2. Okay. Then write. So, by fundamental theorem of arithmetic, there are no other primes in the factorization of 4 is the n. There are no other primes in the factorization of 4 is the n. So, there is no natural number n. For which 4 is the n ends with the digit 0. So, there is no natural number n for which 4 is the n ends with the digit 0. Okay. I think all of you understood. Nothing more, dear children. If a number ends with 0, its factors 5 should be there. 2 and 5 should be there. Here no 5, so it will not be end with 0. Yeah, okay. Write the next heading. LCM and HCF. LCM and HCF. LCM and HCF. Yeah, dear children, in lower classes you've already studied how to find out LCM and HCF. Then, using prime factorization, one more method we are going to study here. Yes. First, let me explain the method. To find out the HCF of 20 and 30. 20 and 30. First, we will do the prime factorization. 20, 2, 10, 2, 5, 5, 1. So, 20 equal to 2 square into 5. Then 30. 2, 15, 3, 5, 5, 1. So 30 equal to 2 into 3 into 5. Then what is HCF means? A highest common factor. From this one we have to find out the common factors. 2 common in both and 5 also common in both. To find out the HCF, if there are more factors, then we have to multiply that common factors. Not all the the method is we are HCF is the product of the common factors with the minimum power. 2 square and 2, which is the 2. 2 is the factor with the smallest power. 2 and 5 both are the same power, so same 5. So HCF equal to 2 into 5 equal to 10. HCF for 20 and 30 equal to 10. For the method I'll tell again. First do the prime factorization and write both one in ascending order by using the powers. Next, HCF is the product of the common factors with the smallest power. 2 square and 2 is there, but you have to consider the common factor with the smallest power. 2 square and 2. 2 is the factor with the smallest power. 2 into, there is only 1 5, 5 with 1 power 1 same, so same 5. 2 into 5 equal to 10. Okay, next. Same way LCM of 20 and 30. Okay, 20, sorry. 20, 2, 10, 2, 5, 5, 1. 30, 2, 15, 3, 5, 1. 20 equal to 2 square into 5. 30 equal to 2 into 3 into 5. Then LCM is, in the case of LCM, you have to consider all the factors includes in the factorization. 2 is there, 5 is there, 3 is there. So you have to consider all. Then no need to consider common factors only. 2, 3, 5, all. Then LCM is the product of all factors with the greatest power. Here 2 square and 2, which is the 2 square is the with the greatest power. 2 square into 5, as I told the same power, so 5, then 3. 2 square, 4 into 5, 20 into 3. So 60 is the LCM. 60 is the LCM. Understood, dear children? LCM is the product of all the factors with the greatest power, and HCF is the product of common factors with the smallest power. Yes. Okay. Write this one. LCM equal to LCM of 20 and 30 and write it. Okay. HCF also are writing? HCF, that also right. HCF of 20 and 30. I'm very sure that you are doing yourself. Simple thing we are discussing here. Very simple concepts. Square into 5. 30. 2 into 3 into 5. So HCF equal to, with minimum power, 2 into 5 equal to 10. Okay, these are the concepts, that means the method of LCM and HCF. Okay, next we write there below that HCF of numbers equal to product of the smallest power of each common prime factor in the numbers. Product of the smallest power of each common prime factor in the numbers. HCF of numbers equal to product of the smallest power of each common prime factor in the numbers. Yes, below that, LCM of numbers equal to product of the greatest power of each prime factor. Product of the greatest power of each prime factor involved in the numbers. Okay, dear children. Next, very important, that means in this chapter, a very important concept related to HCF and LCM is right there below that. For any two positive integers, small letter a and b, for any two positive integers a and b, HCF of AB, can you see here? HCF of AB into LCM of AB equal to A into B. HCF of AB into LCM of AB equal to A into B. Yes, what's the, dear children? That is HCF into LCM equal to, below that, HCF into LCM equal to product of two numbers. HCF into LCM equal to product of two numbers. Okay, dear children. Listen one important thing. This is applicable in the case of HCF and LCM of two numbers, not more than two numbers. Okay. Yeah, very important concept. Yeah, what are the different type of question may ask? Sometimes two numbers HCF only will give. You have to find out LCM. How will you? HCF, if you know HCF and the numbers, then HCF into LCM equal to product of that number. Product of number we can find out by multiplying. Yeah. Then all of you write, one minute, all of you write this one. Yes. For any two positive integers, their LCM into their HCF equal to product of the numbers. For any two positive integers, their LCM into their HCF equal to product of the numbers. So, below that, from this equation, we can find out answers of three different questions. First one is LCM. To find out the LCM equal to product of numbers by HCF. LCM equal to product of numbers by HCF. HCF equal to product of numbers by LCM. HCF equal to product of numbers by LCM. Yes. Then if you know one number is given, how can you find out the second number? That one. Third case, one number equal to LCM into HCF by other number. One number equal to LCM into HCF by other number. Okay, dear children.